Alright, so today let's try to implement Makefile in C. And I mean, obviously Makefile is probably implemented in C already, but I was thinking to try to implement it from scratch and try to see how it works. And yeah, I mean, let's give it a try. And right now I have an empty project, and we can try to copy some stuff from other project. Obviously, one of them is, I guess, initializing a flake, nix flake init. So we have the basic flake, and I would honestly use the flake from the first C project. I was gonna say project name, but this one is a good enough starting point. So let's put it here. We can go over the Nix file itself. It's pretty basic, like it has a description, not even sure if it's used. Then for inputs, I just point to Nix packages, Nix unstable. I guess this has the latest packages. And here it's an environment shell, which is gonna use Clang and Valgrind if we need it for some debugging. Right, so yeah, that's pretty much it. I'm not gonna go into too much detail on how Nix Flake work. Maybe I have to prepare a bit more for that, in my opinion. Like, could be a good idea. But yeah, what we're gonna start out with is ds.h. Obviously, that's a good starting point. So if we just try to wget this file, we'll have that. And one thing we need to do, like I would say we are only gonna have these targets, right? And then like a colon, and then a list of dependencies, and then on the next line we are gonna have a command that we are gonna run. And I guess the important part in the beginning would be to be able to figure out these rules, and let's not worry about commands for the beginning. I'd say maybe just these rules. We're interested in these rules. So imagine that we run our program, and the first rule is going to be the one that's the build rule, right? So we are going to see that this rule depends on main, and then we are going to look in our list of targets, and we're going to find the main rule, right? And we see the main rule depends on these two rules, and we also have those rules as well. And I guess this is like a breadth for search, right? Looks like a DFS or something like that. I guess it's more DFS than BFS because you go in the depth first. Like I'm probably gonna do something like, okay, we found main, then we found ds.o, and then we go into the ds.o rule, and we see these files. And I guess the idea is that if a rule has some targets, or I guess if it has some dependencies, we have to look at the timestamps, like the modification time of each file. But what happens if our build rule is not a file? I guess if it's not a file, it has to run all the time, right? Yeah, I mean it's gonna run all the time, but if main is a file that already exists, then it's not gonna run the other rule. So I think it's okay with this approach. And after we figure out how to build this dependency tree and traverse it, we are gonna worry about how we are gonna add the command. Maybe it's gonna be like, I don't know, an arrow and then the command or something. We are gonna think about that, because even if you have something like make directory A and then make directory B, you can only, like, you can think of this thing as only one command if you do this. So exactly what I'm thinking is we're gonna have the target, then colon, then a list of files separated by space, then maybe an arrow, and then a single string, which is the command. Maybe we are even gonna have like a string like this, and we are gonna, but I mean, I guess you already know how parsing string, like how we did in the past parsing strings, so maybe it's not interesting. But yeah, maybe something like this. And then you might ask, but what about rules that don't have any commands? Fair enough, then this thing should be optional, and that's even better. So let's see our, so this is gonna be our test file, right? As I usually say, it's a good idea to have a test file initially, like you prototype in it your idea of what the input is gonna be like. Now that we have an idea of what we want to build, you know, we can try to start on working on this thing. So I guess a good starting point for creating a parser is the JSON parser that we have in ds.h. And yeah, I mean, we can just try to copy paste stuff from here. So I'm gonna use the same lexing and then parser and so on approach that we usually do in our projects. And I mean, I guess if you don't have parsing experience, this would be like way too, like way of a really sudden start for this tutorial, but you know, for this session of doing some simple coding. But I guess we can just pretend it's fine. So if we open our test file, the main idea here, for me at least, is to parse this thing into an AST, or abstract syntax tree. And this AST is just going to be a list, right? You see everything is just items, and each item is going to be a rule. And the rule is we have a target which we want to create, or in the case of the build target, it's not really a file, but who cares. And then we have some dependencies, which are other targets or files. So that's the idea. And what this thing tells me is that we are gonna have some tokens, because we want to tokenize the file. And if you just look at these tokens, you can see they are just strings or names and colon. Those are the only two tokens that we have in our test file. So that's a good starting point, I would say. So we can just remove most of this stuff. Let's say make token kind. We're gonna have a colon. And the other thing that's interesting is end of file. And I think I'm gonna do make. Another important token usually when parsing files is end of file, because we want to know when we stop. It's similar to how null pointer works for strings. For char pointer, we add a null character at the end, and token illegal just in case we have some illegal characters. But yeah, And obviously the other important one is token. What should we say? Just target, because this is a target. If you think about it, even main is a target, and even ds.c here is a target. But you know, we don't have a ds.c like this and then some stuff, because ds.c is an actual file. So I guess calling it target is a good point. Okay, whatever. So let's go back to ds.h and let's copy more stuff. The next thing that I would take from here is the JSON token, and we are gonna change it to make token. Right, and the make token is gonna contain token kind and a value. Obviously, when we have a colon, the value is not that important because we know it's a colon. But if we have a target token, then the value is important because it's gonna be the name of the target, like main, build, and so on. Sure, here would be nicer if we had the enums from Rust. I always complain about this thing in C, because here you would just say char pointer, right? But it's good enough. In my opinion, I mean, I did how many projects with this kind of structure, and all of them worked. I mean, it's a good point that you don't need Rust. And then we have the make lexer, which is just gonna have a buffer, which is the text that we are gonna read from the file. We are gonna have the length of that buffer. Here, if I think about it, even using a ds string slice would make sense. Maybe we'll try that for this project. We can use a string slice for the buffer, because the string slice has the char pointer, the beginning of the buffer, and the length of the buffer, so it's a smaller structure. And then we have the position, read position, and character. And if you don't know about these things, this is always the project I use for the lexer. I saw it once in like a Golang tutorial for doing a compiler, and from there I just follow this kind of approach, and you'll see why it's pretty good in a second. So let's see. I mean, for printing the we don't really care about printing the tokens, so let's just jump into the util functions for the lexer. So the first one is gonna be pick character, right? So if basically this function looks one character ahead and tells us what character we have on the read position cursor. Like, you can think of this lexer as having two cursors. One is going to be on pos and one is going to be on read pos, and pick character is going to give us the character that's under the read position cursor. So yeah, so here we just return the character from that position. Perfect. Next function is lexer read, which point of this one, do not forget about that, is the make lexer. This one is gonna pick a character, right? Then it's gonna advance both position and read position, and it's gonna return our character. So yeah, straightforward. I mean, you know, they're really simple functions, so hopefully it makes sense. You'll see how we are gonna use them, but yeah. So here I just rename skip white space. It just checks the current character. If it's a space, then we read. So see here, we already make use of these really small functions. This just skips one character in this case. and the character is a white space, as we see there. Okay, so then we have this function to initialize our lexer. So I guess ds string slice, why not? We're gonna pass the string slice directly, right? So we just initialize the buffer, and we want to read one character because we want to initialize our ch, our pause, and read position, right? So after we call to make lexer init, our character is going to be the first character. So that's the idea. And we don't need tokenizing a string. It's a really cool function, but we don't need it. And I really like that I implemented this thing in ds.h because it's like a really good place for a beginner to go and find almost doing anything in C. If you really want to find it, you'll find it. I mean, you can even paste this entire file in ChatGPT and ask it questions. So yeah. Oh, this one. This one is tokenizing identifier. I think this one is fine because we want to parse identifiers, but it's more like we're gonna make some changes here. So this one is a Makefile identifier, but we have target. Right? So what do we want to do here is check if it's a target character, but we don't look only for lowercase. We also want to check other characters as well, like dot, for instance. So let's actually have a function static. Can we use boolean? Last time it was complaining about boolean, but let's use it. Why not? Is target ch, and this thing is gonna get a character char, and we have to check that it's a target. So let's do is lower ch or ch is equal to point, or ch is I guess underscore is a good one. I don't know, we'll see if we need more. I guess uppercase, yeah. Oh, is alpha. Is alpha is a is alpha is alnum is the one that I was looking for. So letters or digits. And okay, whatever. I was thinking if it's a non-white space character, but yeah, whatever. Let's keep it like this. So here is target ch expected. I mean, we can say something like a z 09. It's like regex, right? But got character. I guess. But I'm curious. Oh, this is more like assertion. Okay, yeah, whatever. It's not a problem. Okay, so here, what I was doing here is creating a string slice from the current position, the lexer, with a length of 0, and every time we find one of these is target ch, we increase the slice length. Okay, interesting. So here I just need the str, right, plus the position and so on. And here we read the next. Wait, didn't I just, weird. So if it's a target character, we advance our slice, right? Initially, it's going to start from the current position, length of 0, and each time we find another target character, we increase the length. Hopefully it makes sense. Here we just create a token. Then we convert it into a string. This allocates some memory, but it's fine. And then at the end, I guess we just create a token. So we create make token. The kind is JSON token, no, make token target. Value is 0 because interesting. Oh, we don't even need to convert it into a string. Yeah, we just need to put a slice here, right? Because we tokenize it. And the value is not needed. Perfect. So we don't even allocate memory. That's really nice. Not that it matters, but you know, we just have like a string only one time, and then here you can think of this as just having a pointer into that big string, but we also know its length, so we don't overshoot. Okay, anyways, so yeah, we just created a make token for target. Right, so let's go back to ds.h, and what can we do next? We don't have numbers, but we need this other function, lexer next. Let's just copy this entire thing and let's play a bit with it. So it's gonna be called make whatever, make lexer, and it's gonna return a token. And the point is to always try to return a token, right? So we skip white space. No, I'm curious if I would be able to make these things a bit more generic in the sense of like having macros or defines, and you define this kind of structure and then these just work with this kind of stuff. Yeah, I think I would be able to do that. Maybe I'll try to do it in another part, but for now let's just try to do it like this. So obviously if we find an end of file character, we just create an end of file token, right? If we find anything else, we don't really care about this part, but if we find a colon, we create a colon token. Nice. Then we have some commas. We have the is target, target ch, and make lexer tokenize target. And then we don't have numbers, but we have the error case, which is lexer buffer str. And so for the error case, so here the idea is that we want a function that is going to give us the next token, right? So we skip the white space, we don't care about white space. Then we have like a big switch over the current character. If the current character is end of file, as I said, we have an end of file token. If we have colon, then we have a colon token. If we have a target character, a letter, a digit, whatever, like a file path, we tokenize the entire thing and we just return always. Okay, and on the last case, if we find anything else, so imagine if we find a slash or semicolon, those things we don't take them into account, so they should be an illegal token, right? And we should report that by creating a token with that value so we can print it. Okay, perfect. So that's how we basically parse the tokens. So let's see what's next in the JSON parser. JSON lexer pick. Interesting. I think this one, it sucks. This one sucks. Okay. Lexer position to LC. This one, it's a decent idea to have it. Why not? JSON lexer. Okay. Let's have it just in case. Yeah, why did I say that this function sucks? I found a better solution than doing it like this. Here, for example, what I was doing was storing the initial state of the lexer, then I was taking the next token and then restoring the state of the lexer. And I did that because I wanted to get the current token, but I didn't want the lexer to advance. I wanted it to stay in the same place because sometimes I needed to look one token ahead. So yeah, but I think I can do it better, or at least I did it better when I did the stack lang thingy. Okay, whatever. So this function, decent function for getting the line and column if you have the position in a string. It just computes the line and the column based on new lines, and you know, that's it pretty much. Okay, so the next thing, okay, we have a free function just for resetting everything. Okay, whatever you no, I don't remember how whatever, doesn't matter. It's not like we have anything to free anyways, so it's fine. Next we have the parser, right? So the lexer pretty much, I mean, let's actually have the print and let's test it, because this is also something I really encourage you to do, is to test really often, because otherwise you do what, like you implement the entire thing and then it fails and you are like, oh, oops. So it's a good idea to try to test it as often as you can. So let's see. So this is the make thingy, then we have end of file and illegal, and case make token target. Actually didn't pay attention, was it target here? Whatever, I think it's fine. So we have this kind of thing, and I would say maybe a function to print static void make token print. Not sure. Let's do something like this. So printf. So I'm gonna use printf, obviously. So percentage s for the token kind, right? So I'm gonna do something like make token kind to string, and the token kind is token.kind. I mean, we could even print the position row column, and we can say something like lexer make lexer, but then we need the lexer. Whatever. Let's just print the token. So we showed the token kind, and then if token dot kind is equal to make token target, we know that we have to print something more. Well, if it's target or illegal, that's when we need, or the other easy way is if value dot len is greater than 0, right? This is the easiest way to check that. So let's do printf, and I'm going to use parentheses, and is it like this? I think it was. So with printf you have a bunch of like this kind of operators, and one that I always use with string slice is being able to print a certain number of characters, and you do that with, I think it was star. So if I say token.value.len and token.value.str, it's gonna know, okay, I have to print this many characters from this pointer. So if I wouldn't use the length, it would print too many characters because this is a pointer inside of the entire file. So it would print from the pointer until the end of the file, and we don't want that. We just want to print this many characters. But yeah, that's hopefully makes sense why. Maybe I don't know if I had this string slice, would be not. Yeah, I don't know. I think it's fine. It's fine to have a printf like this. Okay, so that's how we are gonna print our make tokens, right? So finally, the next step, let's just copy paste. Let's have a parse arguments. Let's have a parse arguments, and this parse arguments, oh I already forgot. Okay, it's gonna take in a file make, a clone of the make CLI tool. It's gonna take in a file, the file to use for make, kind of, and it's gonna be a positional, so a single file, right? And we have this thing, and here it should be a char pointer file. Okay, we don't need that. And we should have this rparse get value, and we pass in the parser file, and I think this returns a string. Yeah, so args file is equal to that. Okay, perfect. So that's how we are gonna parse our things, and we are just gonna copy paste this stuff as well. So this is just the argument parsing, which we saw how to do last time, so it makes sense. And the last thing would be to just IO read, right? That's all we need to do. IO read. because we have a file. It's in args file. Okay, whatever, it's with dot, and we read it into content. And we have content and size, so we can easily build a string slice. And we are gonna do that here. ds string slice init. Oh, let's say it's equal to 0. And then string slice init. It takes in a slice. I think it was content and size, right? Yeah, content and size. So that's how we are going to initialize our string slice. And if you remember from like 2 minutes ago, we had this lexer init where we are going to pass. Oh, let's make lexer. We are going to pass it here, and we're going to pass in the slice in here. Nice. This can fail for some reason, but it's already 0. Okay, so cannot fail actually. Perfect. But yeah. And the last thing was make lexer next, and this thing is gonna take in the lexer and the token. Make token, right? And we can do something like do. I actually became a fan of the do while loop. Do, like before, I would be like, yeah, do while loops suck. But now I'm like, maybe they're actually useful. Whatever. We read the next token, and then we have the make token printf, which should print our tokens. And let's see, we're gonna so 107, it says that it likes this more. Okay, whatever. And then we have some unused variables, 116 and 146. Unused label, really? Yeah, it's unused. And the last thing is 131. It complains that this position, is an integer, while this thing is an unsigned integer. So it doesn't like that, but the thing is that in the lexer, I think this is, oh, it is unsigned. Okay, perfect. I mean, the function is unused anyways, so, but I really like it, so let's keep it. Okay, unused functions. Fair enough. Let's remove. Let's actually comment it out. Huh. Yeah, whatever. I'm just gonna comment it out. And make lexer free. We can just say here make lexer free. Lexer. I mean, there's nothing too free about it, but ds string slice init 190. I mean, it is here. Do I need to define the SS implementation? I thought the SS implementation is interesting. Okay, and this one takes in a file. So if I give it a test, no, actually it looks bad. But why? Like it's exactly what I said here. It's funny. See, it prints the entire text. But why? Isn't token percentage D? Let's see. Maybe I did something wrong with the token. It's not always gonna work, but let's hope. No, it looks fine. Here it says 6. Or am I wrong with that? I was thinking here it says 4 and the text is main, right? Yeah. Here it says 4 and we have this stuff. Here it says 6 and it's main.o. So I'm printing something wrong. Was it dot star? I don't remember. Yeah, it was dot star. Okay. Perfect. So actually it's dot star when you want to print a certain amount of characters. But yeah, you can see it's perfectly reading our Makefile, which quite nice. So the next step, as I said, is to build this into an AST. So we already know that it's actually going to be hard to build an AST. Let's go back to this and let's add another token. Let's say you have to add a semicolon at the end just to make things a bit easier for now. Usually, that's why some languages have semicolon, because it's really easy to say, okay, here is where the instruction ends. So it's easy for the AST to do stuff. So let's say semicolon. And we're gonna have the semicolon here, and that's gonna make our lives a bit easier. So when we add a new token, we just have to come here. Well, what? Okay. And yeah, we just create a new token. Pretty easy, I would say. And now we see target build, then colon, and then some other strings here, and then a semicolon. We know that this is a target, this is another one, and so on. So yeah, let's build the. So we go to this.h. Oh, JSON. I think it was like line 2000 something. Okay, yeah. So now we need the JSON parser, which, as I said, I found a better way to implement it when I did the stack language. So before I was trying to do it like this, where I had a reference to the lexer, but what I realized is that it's much easier to also have the same kind of structure as the lexer itself. So we have buffer here, right? And instead of buffer, we have lexer for the parser. But what about these other things? Would be nice if we could have something like this here, right? Would be nice. We don't really have positions because the position, I mean, it's the token index. We don't really care about token index, but what we care more about is the token, which, I mean, here should be make token, and the next token. I think that's how I was naming them. Token and next token, I don't remember actually, but I think it's much better to have this, like, it's really similar to lexer because it has the thing, the text or the list of tokens, and then it has this position and read position. So instead of doing peek using that weird function that I had before, we just look at next token and you pick like that. Obviously some of these functions won't be useful anymore because of that, but still fine. So to initialize the parser, we pass the parser, we pass the lexer, right? And let's think. No, it's been quite a long time since I did this parser before, so I don't remember exactly how I wanted to initialize token and next token. I think we need to do read twice. So I would do something like make lexer next, like this, and here we're gonna pass reference to the lexer, but let's do parser lexer. Let's do it like this, and here I'm gonna do reference to parser dot token. So we're gonna parse the token, and I think we want to parse next token as well. So now we have the token and the next token. Although for this parser we don't really need to look ahead, it's really easy, so we don't need this stuff, but I still think it's really nice to have, so yeah, whatever. Okay, then we need some other cool functions. We can steal these, peek and read. I mean, I should have implemented these ones. Make parser peek token. So here it's parser. This thing, what it's supposed to do is to just return the token, I think the current token, return parser toc, oops, make token, I think, and make parser read. Make token, I think it's, let's think about it. I guess here I should return the next token. Maybe this one, it doesn't make sense though, doing the peek. So maybe what I should do instead is read into next token, right? Something like this. We read into next token, but before that we swap next token to token. So we do something like parser toc is equal to parser next toc. So it's basically this part right here, and then we return parser token. So that's how I would do read. Right, so then instead of this part we can just say make parser read parser, and we do it, should we do it twice or once? Not sure. Let's do it twice. Why not? So now at this point, talk is gonna contain the first token. Okay, whatever. Right. So we'll need something like make parser parse target, or maybe we call it rule, and we have a make parser, and then we have a make rule. Right, we don't have the structure, but what it should be, okay, let's type def struct make rule, and it's gonna be extremely easy. It's gonna have a string slice for the target, and it's supposed to have a dynamic array for the dependencies. Let's call it the dependencies. It's kind of long. Let's say depths, and this is going to be a dynamic array of string slice. And you know, as I say every time I write a dynamic array, I like to put a comment with the type. Anyway, so this is how we are going to parse a rule. Great. Okay. So parse. I want a simple one. I would like a simple rule. So I guess int result. Yeah, I was like, probably this part I wouldn't be able to factor in such a way you can write a generic parser. I'm not sure how I would do that, but yeah, would be cool. But I don't know how to do it, so let's not worry about it. So JSON lexer next. Interesting. Well, I mean, we already have the current token. It's called talk. So we should just check that we have something that's useful, right? So something that's useful is parser.talk. So we need to look at talk, and that's gonna be our token. Let's put it like this. So if token.kind is not equal to make token target, then it's bad, because it means it doesn't work. So I would like to say something like expected blah blah blah. So expected target, but found yeah, whatever, something. And here we need to say make token to string, and then line and column. And for the line and column, we actually have a use now for this function that we commented at some point here. Right, perfect. So yeah, it's gonna say okay, that sucks, and then we return before 1. Okay, so if we don't find a token, right, and if we found a target token, then that's great news. We can just say rule target is equal to token dot value, right, on the else case, pretty much. And the other thing I would do is initialize the rule depths. And yeah, since I said it's a string slice, we just initialize it with string slice. Okay, but it wants a reference. Okay. And yeah, I mean, I still do dynamic array init. Even if we don't need it. Yeah, whatever. Then we need to make parser read. We need to read the next thingy. So obviously here we pass the parser. And what's nice is that this should return the next token, right? Yeah, so we can just say, yeah, like that. Let me just initialize the make, yeah, the OCD kicks in. Okay, so we take the token, then we read the next token, and we expect token kind to be token colon, and if it's not, then sucks to suck. Expected a colon but found something else. Doesn't matter, it's kind of the same error. Okay, and then we do another read, and from now on we expect to find a bunch of tokens. So do, we're gonna do while loop. Interesting. Do while token. Let's think actually about it. I want it to be a do while loop because we always have at least one dependency. So yeah, I want it to be a do while loop, right? Maybe, oh, maybe this thing should be inside of the do loop. So we do this stuff until the token kind is not make token semicolon. So when we find the semicolon, that's when we stop. And that's why I wanted to add this semicolon token, because we need a way to tell this while loop when to stop. Right. Well, if I didn't have the token semicolon, we could have made use of this next token. But yeah, let's keep it simple. Okay, so here we read a token, and we need it to be, we need this token to be a target. Although I can say here something like if, actually, let's make it a while true. It's easier. So if token, oh, if token kind is equal to semicolon, we break, and otherwise we need this part. Right. And ds dynamic array append into rule depths. We want to append the token value again, and this should be ds unreachable, which just checks for errors. So that's basically how we are going to parse rules, or a single rule, should I say. And if we go next, we are going to create another structure. So that's make rule, and let's say make file. I don't have a better name. It's funny, make file. And the make file is going to be a dynamic array of rules, right? And it wants the thingy. So let's copy paste this thing, and this is gonna be make parser parse make. We are building a parse file. So here we have a make file. Let's call it make. Why not? And I guess it's a bit easier. Obviously, it's easier than this one, but I'm just gonna copy paste it because I like copy pasting. If you are able to copy paste stuff, then it means you are doing a good job. Don't quote me on that. I don't want to appear in a lawsuit against a university teacher. So, okay, we initialize our make rules and we start with a while true right away. Right, so we parse a single, or I guess we read a single token, and if we find end of file, we stop. Okay, makes sense. We find end of file, we stop, it means we read all the rules. Then, regardless of that, we should always attempt to parse a rule. So we should always do this thing, parse rule, we pass in the parser, and here we need to pass something else. What is that? It's a rule, so it's a make rule. Make rule is equal to 0, just to have something, and here we pass in the rule. So we parsed it. Here we should check if this thing is not 0. We return before 1. I'm not gonna show any other logs, I'm just gonna crash it basically. And at the end, if everything was fine, we should append the rule to the rest of the rules. Okay, I guess that's all, right? So this is going to be used to parse a makefile. Let's create a makefile. So make parser, it's going to be a parser, make parser init, parser lexer, and here what's nice about this init function, you see the lexer is sent by value, so you make a copy of the lexer, you don't modify the lexer via the parser. So if I run the parser now and then run this thing, it should be fine. If I do it in this order, it's not fine obviously, but if I do it like this, should be fine. Although we don't need this stuff anymore. But yeah, whatever. So here we initialize our parser. It's not gonna like this part, but what I'm gonna do, I'm pretty sure the makefile from here, no, not this one. No, I guess it's in the full compiler. Usually add this no unused parameters or no unused function. It's like, it's a weird error to keep. No unused function, because yeah, I mean, we are building something like a library, so. Anyway, we initialize the parser and we need to parse the makefile. So, oops. Parse the makefile, we send in this stuff, and then we need a makefile make. So we parse the makefile. If this thing is not 0, we just return 1 directly. I don't even care. Okay, so this is gonna parse our thingy. Now, would be nice to have a function that prints this structure, and let's do that because now I like to practice using my own library. So it's a makefile printf. So it's gonna take in a makefile. Let's say it takes in a copy. Why not? So what I'm gonna do here, unsigned int I starts from 0, I goes until make rules count I++, and here we are gonna have a rule, initialize it with 0, and then this dynamic array get, we should read from make rules. Wait, what? Oh yeah, we read one of these rules, and then I should have something like make rule printf, and this one takes in a rule, but we don't have the function. So let's go over here and let's implement that function. So make rule. I'm curious, Copilot. Let's see if Copilot knows how to print my rule. I mean, looks fine. I mean, it's exactly the same thing as not parsing it, but I think it's still good. So if you didn't catch it, it prints the target, so this thing, this slice, then it iterates over this dynamic array, it gets it from the array, this thing, I mean it's also ds unreachable, but it doesn't know that, and then it prints all the dependencies. Looks good, I'm not gonna lie. So yeah, okay, and this unreachable, perfect. So I think if I do makefile printf, and I pass in the make, we should, oh shit, but found, what are you smoking? 206. So here it shit itself. Well, you know, it's interesting. Why would that happen? Do I need to run read once? So, oh, because I read it here. Oh shit. I guess I shouldn't use parser read. I should just say parser token. But I mean, that's pretty stupid. Why wouldn't I just do that? And then we don't even need token. But found. Okay, expected the target, but found. Oh, you know why? Because here, if we find a semicolon, we should skip it. So we should run this this thing. And yeah, why not? Yeah, we should skip it. Yeah, makes sense. Wait, is the rule? I think so. Yeah, I guess it makes sense. So I was thinking, should we put this read here or after we call the function? You know, you can make a case for both. Like, is the semicolon part of the rule or is it just a separator for the rules? You know, I guess I'm gonna keep it in there. I don't want to think that much, but you see, it's actually really nice. It parses the rules. So yeah, that's a good first step, I would say. So the next thing would be to actually, let's say, plan the build. So we it just came. Jesus, the idea of calling it, what did I say? Plan. It just came to my mind. Yeah, whoops. So I'm gonna call this one make parser, or I guess make plan, static void make plan, and I guess the plan should take in a makefile this structure, and it's not necessary to be a pointer. So yeah, luckily for us it's pretty similar to this, although not really, because we want the first rule. So we want to say make rule. Actually, let's let the user now. For now, let's just run the first rule. Let's keep everything extremely simple for this project. Let's not worry about being able to specify which rule you want to make. In fact, the other stuff, like being able to add an extra argument and adding here the extra argument and then starting from a custom rule, it's gonna be a homework for I mean, if you got to this point, it has to be a homework for you. Like, come on, what are you doing? Okay, so I mean, you're gonna make a PR to this project. It's gonna be fun. Okay, so the rule is gonna be the first one, as I said. So it has to start with this dynamic array get. We're gonna place rules 0 rule. So is the first rule. It's you know, pretty easy to get a custom rule because you just pass in here the name of the rule, maybe a dynamics like a string slice, and then you have to search the index, and instead of 0 use that index. So I even gave you the tip of how to do it. Okay, so we are gonna get the first rule, and what do we want to do next is a DFS. Interesting. I don't think I have a queue structure. I don't have a queue. It's a priority queue, but it's not a queue. No. Okay, whatever. Well, we can use a list as a queue. It's easy. Right. Or we can use the linked list. I have that data structure as well in there. Anyway, So we got the first rule, right? And let's have a separate function, static void make plan dfs, and this one is gonna take in the make and the current rule. It's gonna take these things and the current rule, and make plan dfs is gonna take make and the rule. All right, so what should we do here? Well, we need the dependencies from the rule, right? We have some dependencies here. Obviously we can steal this thing, right? We have the dependencies, we get the dependency, and now we should say something like, let me think. Maybe the first thing is saying here, we'll build %s and then rule dot target rule dot target dot str, right? We can say something like this. We'll build, or maybe just build, compile, execute, whatever, run. Okay, so now we have the dependency, right? That means we have to run the dependency. But what I would like to do first is search for the dependency in the rules, so we can do a make plan again. That means, I mean, it's similar to that, but not really. So make rule, let's call it dependency rule, is the rule of the dependency. And maybe a bool found is equal to false, because if we cannot find a certain rule, it better be a file, because otherwise we are missing a rule, right? So hopefully it will make sense after I write this for loop. Unsigned int j is less than make rules.count j plus plus. We also make like an assumption that we won't have cycles in the Makefile. And I was solving those problems, like, who cares? So yeah. So here we have a make rule. We already have it. So let's just read it. So ds unreachable, ds dynamic array get make rules j, and we read into dep rule. All right, and if ds string slice equals, this is the string slice and the other string slice. So if the dependency is equal to dep rule.target, it means that we found, it means that we found the thing. I think this has to be, both of them have to be references. It means that we found the target inside of the rule, so we can break. Otherwise we didn't. Okay, so if found, we should print something like this. Run, and here we should say dep rule. So that's the dep rule. Right, hopefully it makes sense. So we get a rule, I was thinking maybe we should just print here like that, run the rule, and then right, maybe here if found, what we should do instead is call this thing recursively. So make plan DFS with the dependency rule, and if we didn't find it, we should say maybe something like rule is a file or something. F %s star s \n dep. So this thing is a file. dep.len dep.str. Maybe we should say just file or something like that. Okay, and let's try to make plan. Oh, make plan. So it's gonna run build, it's gonna run main, ds.o, it found this as a file, this as a file, run this. Okay, so I guess then instead we should put this at the end, the run thingy, right? So it found this file, based on these two files it's gonna run the ds.o command. We don't have it yet, but we'll add it. Then it found these two files, it's gonna run the main.o command, then it's gonna run the main command and the build command, which, I mean, there's no build command, so yeah. I think that's a pretty good point for now, right? Like, we have a plan at this point on how to reach the build command, and next stop would be actually having like real commands in here, being able to run them. And I'm pretty sure that would be interesting on its own. Like, how do you run commands from C? That's a good idea. So maybe in this one I'm also gonna add, so if we go to the test file, maybe I'm also gonna add the arrow and the command like clang, whatever, you know, clang ds.c -c -o ds. Maybe it's a good idea to just -o, and here right, maybe it's a good idea to add this stuff right now, and then next time we look into how we can execute commands from C. I mean, you can even do your homework. I'm just kidding. exec vp. Oh, I don't have it. Whatever. Doesn't matter. So main file. Because yeah, it's kind of interesting with this new token that I just added. Right, so what I said from the beginning, we'll have like an arrow and then a command, which is just a big string. So let's make token arrow. Oh, case make token arrow return, and this is the arrow. And obviously we need here something similar to this, and you know it's kind of lucky that we know if you have an equal sign, it's automatically gonna be an arrow, right? So we don't even need to double check, although yeah, we should, but I'm gonna be lazy, you know. And in fact, let's make it be just equals. Let's make it equals. All right, so when we find the equal symbol, it means that that's the rule. Yeah, I mean, you know, if we needed multiple symbols, I would say let's use an arrow, but let's use equals. Okay, so that's when we are gonna have equals, and the equals is gonna be optional. So let's go now to another idea to make things a bit easier as well is to just use quotes. There is another token. So make token equals make token cmd, and this is going to be a cmd. So that's the command, right? And I want to do that because if we find it's in this.h JSON I had that JSON tokenize string, which pretty nice. Why shouldn't we just include in our project this beautiful function? Yeah. So make token, right? And the idea is we find quote, then we start with str, we read the next token. I mean, maybe explain what this does a bit. So while we don't find a double quote, we read the next character, and we have to be careful about escape sequences because we can have escaped double quotes, which are not the closing double quote, but they are just double quotes inside of strings. Like here, for instance, this is an escaped double quote, right? So we have that because we can have commands in our test file that for some reason they can have escaped quotes, so we have to be careful with that. But other than that, pretty straightforward, I would say. So this is the make token string. I don't have it, right? Oh, it's make token command, make token cmd, and we pass in the slice. Extremely simple. And then let's just copy paste this thing. Oh, actually, ds.h, and here let's just copy paste how is this one used. So if we find a double quote, we just parse the string. I'd say it's straightforward parsing the string, but what we need to change now is, and if you made the guess, that's right, we have to come here. And the idea is that if we find a semicolon or an equal sign, then we have different behaviors here. Right. So I'd say maybe we want to just break. So or token kind is equal to make token c equals, right? And here, if token kind is equal to make token semicolon, just stop. And otherwise it means we have a token equals. So what I'm gonna do is something like this. We need to read here and here as well. We need to read it. So if we don't have a token CMD, it's bad. Expected a CMD but found something else, right? Nice. And at the end we need to set the CMD on the rule, and of course we don't have a CMD yet, but let's just add one. Oh, and the other thing is we need to do another read, and now we need to have a semicolon. So if we don't have a semicolon, then we are cooked. Expected a semicolon, and then we need to read one more time to skip the semicolon, I guess. Okay, so let's add in here the CMD, and now it should be happy about the CMD. Maybe the other thing we want to do is to print the CMD. So in here, oh, well, yeah, because we can tell if you have a CMD or not. So if rule.cmd.len is greater than 0, you have a CMD, otherwise you don't. So I'm gonna say printf equals, and then maybe I'm gonna use double quotes like that. Yeah. Okay. So rule cmd len, rule cmd str. Perfect. So I guess that's oh, where is that? 109. Sure, whatever. Okay, and now instead of showing just run, maybe we want to show the CMD. So rule.cmd.len, rule.cmd.str. Right, so we found these files, we should run this command. We found these files, we should run this command, then this one, and run build. This one doesn't have a command. Okay, yeah, whatever, doesn't have a command, then we don't need to run it, right? So that's the idea. I think that's a pretty good place to stop. So yeah, what we'll have to do is to just run this command. So we need to run stuff from C. Not sure how it's gonna work with Nix. Hopefully it's gonna work. And the other thing that we need to do is to check that this file is actually needed. So if these files are newer than ds.o, we need to run this thing. If they're older, then we don't need to run this command. So yeah, I think that's pretty much all that's left. So just the second part should be enough. So yeah, hopefully this was interesting for you. I mean, 500 lines of code, yeah. It wasn't that difficult. It was more just taking code from the JSON parser. But now, you know, I have more experience because we also did more parsers since then. So we made a bit like a few changes. Yeah, for now I'm pretty happy with the results. So yeah, we'll have to, what's left here is to make sure that the rule is actually needed. So we need to run the rule if the dependencies are newer than the target, and just figure out how to run commands from C. So that's something, you know, that's really useful. So it's worth to be closer to the start of the video when people are actually watching. So yeah, that's why I want to split it into a second part. So yeah, hopefully it was interesting, and we'll see in the next one. So see you.